Chris, thank you.
All right, you're welcome. Okay, so before we start, like two brief organizational announcements. First of all, I'm sick like hell. I woke up this morning really sick. So if I don't make any sense today, I'm really sorry about that. Maybe if you have to come the next time I'm talking, maybe then it'll make more sense. And also, they have a second surprise speaker from Mozilla who's on his way here. So that person might join us shortly. We're going to get started in the meantime. So today I'm going to talk about the boot-to-gecko project, and really is behind that is an attempt by Mozilla to take the open web and apply it to mobile devices. And I'm going to go back in history a little bit first. I'm going to explore why we think that we are successful on desktop and why the desktop web looks like the way it looks like today, and then we're going to transition from there, why mobile is different, and how we can make mobile look a little bit more cheerful than it is today too. So first of all, Mozilla, some of you might not really know who we are or what we do. Most of you probably know Firefox, the web browser we make. But we have around, I think this number is a little bit outdated, it's probably close to 500 million users. They've been localized in many different languages. Behind Mozilla is a foundation, a non-profit foundation, the Mozilla Foundation. And this foundation actually owns the corporation, the Mozilla Corporation, that's the entity I work for. And the foundation basically uses that corporation for software development purposes. So we have a small army of software developers, around 650, I think today it's more like 700. People who are developing Firefox and other products, such as the project I'm going to talk about today. And the Mozilla open source effort goes way beyond this corporation or the foundation. So we have a large number of contributors, thousands of people have contributed over time to the Mozilla code base and Firefox and all the other products we have. And we also have a large community of add-on developers who work with us on extensions. So there's 140,000 extensions for Firefox. So that's kind of the background of Mozilla. Now, how did this all start? So to understand that, it's important to understand where Mozilla is coming from. So Mozilla's history really is that many years ago, a company called Netscape, that some of you might remember, had this idea that they're going to make a browser that's going to be great. They're going to make a browser that you can use for free, and it's also really the first serious browser out there. The business model was that you use it for commercial purposes. If you're a company, then you're going to pay them some money. And it worked fantastically well, browsers became really successful, the web started really to take off, and unfortunately another company called Microsoft, that some of you might know, came in and decided they're going to be the same business with a slightly different business model. They're going to give you Internet Explorer for free if you use it non-commercially, and they give it to you for free if you use it commercially. So that, of course, was really bad news for Netscape, since they're kind of like out of the business model. There was actually something even more sinister behind that, though. As IE started to take off and become more popular, in particular because it was distributed to the operating system, what Microsoft did is they started putting all sorts of proprietary technology into the browser. They invented something called ActiveX, for example, which is basically a way to run Microsoft-specific native code inside the web platform. And Netscape was facing, in addition to the business model issues, also the problem that they simply could not copy that. You cannot reinvent ActiveX. It's technology only really Microsoft understands how the hell that works. So there was really two problems, the business model, but also if you allow stuff to be put in the web that's not open, that's not based on standards, then suddenly anyone else but the person who's driving that can no longer compete. So this is where Mozilla came in. So Mozilla came in and was founded as a dying act of Netscape as an open source effort trying to compete with Microsoft. And today we have arrived at a point where we have 30% global market share, give or take. We are #1 browser in Europe. Across the world, we are somewhere between second and third in global market share. And this is really important for us because this is the way we are influencing the web. But it's not really the actual goal. So Mozilla is not a software corporation to make software. We are really interested on the standards and the web behind it, and making Firefox use a tool for that. So let's go back a little bit to this period I just talked about, the year 2002 when IE came out. The first observation, for those of you who can remember these times, is that the web back then really sucked. Having to serve the web's IE was really terrible. And the reason for that was that there was not a lot of competition around. So Microsoft managed to push a lot of copies of IE out, and there was not a lot of ways and reason for Microsoft to improve the web performance. And today, the web is a very different place. So there's multiple different browsers. There's, of course, Firefox, the one that we are making. There's also Chrome, there's Safari, and actually Internet Explorer is back. For a very long time, Microsoft made this a really crappy browser, IE6, 3-year structures for a long time. And they have switched gears quite a bit. So now there are several new versions of IE out. They are significantly better than IE6. They are quite competitive on many aspects of the web stack. And this is Opera, another smaller browser that's popular in Europe. So the biggest change that happened is that the web today is really mostly based on open standards. So instead of in the past where we had stuff like ActiveX that was really important for a complete web experience, and some of the things you could not do without having that piece in the mix, that's today more or less irrelevant. Most of the things really happen in HTML5 using open standards, and on top of that, we are running some standards-based web pages. And that's really the reason that all these different browsers are able to implement that. So how did we really get here? Well, I think Mozilla had a really big part in that, and the tool that Mozilla used is to push on these open standards. The first thing was missing years ago on the web is that many things you could not do with the web. The web platform was very narrow. It was built around that you can look at a document and then you can do a couple more things with it. But it was not a very rich platform. So that's what really Mozilla has been driving, along with a couple other companies over the last couple of years, is to create extensions to the web platform. And that's really what the main contribution of browser vendors is these days. Browser vendors independently are pushing new web standards to extend the web, to add new capabilities. And this creates a very competitive environment where people are adding constantly new cool features. And they're also competing over who implements the existing features that are codified as a standard in the best way. So that's really the key concept behind making the web successful is intolerable standards. It cannot be something like ActiveX. If there's any Mozilla-specific technology and it's in Firefox that the other vendors cannot implement, then they cannot compete with us. However, instead, if you're making some open standard that everyone can implement, then we can all compete over who implements it best. And that's actually what you see happen often on the web. And I think this is the explanation why the web is moving at such a fast pace. As an example here, I have a little graph here. I think it's 2 or 3 years old. Google came out with a new benchmark. It's 2 or 3 years old by now. It was called the V8 benchmark. And when that came out, we benchmarked it, turned out that our virtual machine, or JavaScript VM, was quite a bit slower than the competition. They were like 2x or so slower than the Safari and Chrome version. And this is not, if you, from a technical perspective, if you load a web page, we were not twice as slow loading a web page. It's just this specific benchmark, we were twice as slow. Now, this benchmark is not even all that relevant, to be honest. So most web pages, performance is not affected by this benchmark. But it totally didn't matter. Because immediately when this benchmark came out, the press started jumping on this and benchmarking. On this benchmark, they are slower. So this put competitive pressure on us. What we basically did, we hired a big team of very smart people who can build compilers and started optimizing our JavaScript engine until we were as good as a competition. And as you can see on the time scale, it is very quickly. This is from August to October. We invested a lot of money and time and people and sweat to make our JavaScript engine competitive. And you can see this all over the place. Every time a browser vendor adds some cool feature or makes something in one browser faster, all the others are immediately under pressure to do that as well. So every time Chrome adds some cool API that developers like, developers are going to turn to us, hey, why can't Firefox not do that? We have to implement it. And it's pretty much the same other way around. Firefox adds something, Chrome is implemented, Maestre is implemented. And in the middle sits the idea of standards bodies. So there's a couple of standards bodies. W3C is the most important one. And it basically codifies what kind of people agree on is a cool feature. So the web setup does not really start with standards. It's rare that you make a standard and everyone goes implements it. It's usually the other way around. Someone comes with a cool API, implements it, and then others pick it up, maybe in a slightly modified form, and we all meet in standards bodies and figure out, okay, what is really the one uniform interface we would like to have. So what's really cool about this is that this basically allows browser vendors to compete over the same features who can implement them better. And you benefit from that because you get really awesome fast JavaScript engines. So the last 3 or 4 years or so, JavaScript has gotten massively faster because exactly of this game theory behind it that everyone has to compete. Now let's compare that with mobile, right? Desktop's great. Everything is getting faster. You have choice. You can use Firefox. You can use Chrome, and you can look at the same web pages. And we all have to compete over who has a better implementation of the standards. And you get to choose what system you use. Now, the mobile landscape is very, very different. So it does not really matter what particular platform we choose. Let's start with Android. So in case of Android, you get a device that is based around Google technology. There's the Google Target VM, there's a bunch of Google APIs for Android. It's completely driven by one vendor. In addition to that, also a bunch of interesting pieces on the platform that you can monetize, such as services and maybe payments or a store, they're all owned by Google. So there's also the notification services Google owns, there's the ad network Google owns, there's the store Google owns, and the platform itself, the actual technical details, are owned by Google as well. And what I mean is owned is that no other party than Google has any influence on that. If you have a really cool idea for Android, what kind of API you could do, good luck to you. If you're not working for Google, it has no meaning. So they are a complete exclusive owner of the platform. And that's really a problem because Google can basically single-handedly determine the direction of that mobile platform. That's very different for the web. Mozilla has no exclusive control over what APIs go into the web. You cannot stop anything, and we cannot force anything in. All they can do is kind of influence. If you do something cool, chances are others are going to pick it up. But if we are slow on doing it, someone else is going to come and do it for us. So it's an open environment where people can compete where the best ideas win, not like one particular company's idea. Now, of course, what's really bad is the setup that it leaves a bunch of parties out. So if you're a user, it really sucks for you because the platform itself is completely based on proprietary technology by one vendor. So if you buy an Android device and you buy your favorite Angry Birds game on it, you can't simply switch to a different platform. So let's say you want to switch to iOS because you really like Apple. You can't because the Apple platform is completely dominated by Apple. It's got Coco and RGPC and Maestre, and it's completely separate. You cannot exchange apps between them. And of course, Apple uses the same kind of login. That you have Apple services, Apple ads, the Apple Store. So they use the fact that they own the platform, the direction of the platform, to technical control. They lock in all of the service parts as well. And then Windows Phone 7 is Microsoft attempt to replicate this kind of silo on their end. And for users, it's really bad because you can't switch between these platforms. Once you are stuck with one of them, you're really stuck there. But actually, there's a bunch of other parties that are really screwed by this as well. Most of you are developers. You already know the pain that this causes developers. You have to develop everything for these 2 or 3 platforms. There's a lot of investment and effort to develop for these different toolings. But actually, all the operators are really in a bad position here. Because all the things that you can really monetize about, all these services and value-added services, the operator can offer. And even beyond that, actually, if you ask people what kind of phone they have, they're going to tell you I have an iPhone or an Android phone. They're not going to say I have a Verizon phone or AT&T phone. So the operators lost the relationship with the customer. You're really thinking of your device as a Google or Apple device. You have Google or Apple account on it. You're buying from Google or Apple. So all these additional opportunities to make revenue are go to the platform owner, not to the operator. So operators really don't like that kind of stuff either. It's very close. And actually, even the OEMs that make those devices really don't like this setup. In case of Android, they have actually very little way how they can customize the device because Google really wants the software to be shiny and has certain requirements on the hardware. They can get to the point where it's very hard for OEMs to really differentiate. All these Android phones are more or less the same. Google is kind of squeezing out the opportunity for these different OEMs to make any changes to the device. At some point, we'll get to the point where they can kind of change the plastic around it. That's pretty much going to be all they can change. All right, so how can we change that? Well, we think that on the desktop this works very well. Simply you just go ahead and start innovating and we add new cool features to the web. And you're going to create an environment where the web is competitive with these platforms. And then you should be able to do the same thing on desktop. Then you can move to an environment where the web can replace these native stacks. And this is really pretty much what was the case in 2002. Windows 32 was the ecosystem. That's what you wrote the software for. Today, you're running the same software for the web. What really changed is we added a whole bunch of powerful APIs that allow you to build stuff as a web that's as powerful as Windows 32 back then. And it's important to note that today on mobile devices, that's not the case. Until recently, when we started adding a whole bunch of new APIs to the web to support mobile devices, almost all the stuff that you can do with a mobile phone was not supported on the web. You can make phone calls, you can access USB or Bluetooth. All the key hardware capabilities are not exposed to the web. So that's really pretty much the reason we think that the web is not successful right now on mobile devices, and these native platforms are, because the web is simply not good enough. So that's what we have to fix. We have to make the web as good and better as these native APIs, then people actually can go and start building applications with the web. So what we're trying to go towards is a system where the web is in the middle, and we use the web platform as the actual application platform. And this idea of like native apps on these devices should replace this idea of web apps, which are really apps just based on the web platform. And all these individual services are currently implemented using proprietary protocols. We should define a bunch of APIs and protocols from web services for those. The goal of this is to create an environment where all the protocols, all the standards, all technology is completely open. Anyone can implement them. So as a result, people can go ahead and implement the client side of this, and that's what we're already doing. So boot-to-gecko is really just an implementation of this new world that we are envisioning. But ideally, you should not be the only implementation. So this is not the boot-to-gecko ecosystem. Boot-to-gecko is hopefully just one of the implementations. Right now it's the first, but hopefully it's going to be soon other implementations. There should be Google implementation, Apple implementation, maybe some Trident-based Maestre implementation. So the goal really is to create the same kind of competition we have on desktop today. Create an environment where the technology is open and people can come and implement it. And of course, this also works on the other side, on the actual service provider side. So suddenly all these parties that were locked out of this can go and provide all these services. So operators can go and build some services or app stores. Mozilla can do that. This is one of the motivations behind us doing this. We think we can run a really cool app store, and unfortunately we can't. On Apple, iOS, for example, you're not allowed to offer any of these services that would compete with Apple. So we would like to create an open environment where we can do that, and operators can do that, and maybe third parties like Amazon might be able to do. And then you, of course, if you think that you have a cool idea, you can run a store, we want you to be able to do that. And it's important to also think past the current idea of a store, right? You click on a grid of icons and a thing pops open that looks like a marketplace. That's what we think of as a store today, but I really don't think once you create a system that's based on the web that meshes up as nicely as the web does, that a concept of marketplace is going to look anything like the iOS iTunes marketplace like today. So I think things like search, app search, integrated discovery of apps, and functional search of apps, it's much more likely how you're going to discover content. It's kind of apps-like content on mobile. So that's exactly what we would like to enable. Now, as I already said, the key problem that we're facing is this, is that a lot of the APIs that you need to make really cool apps on mobile didn't exist on the web until 6 months ago. So that was really the first step for us in this project, is to say, okay, what is all the stuff that you can do with native APIs that you cannot do with the web? And that was actually quite a bit 6 months ago. So location, audio, gestures, contact, telephony, all the really basic stuff. There was a lot of things missing. So this was the initial focus of the project for the first 6 to 9 months. Basically, we set up the goal is anything you can do with a native API that you cannot do with the web is a bug. Should there be a file somewhere, and someone should be working on it right now to fix that. And actually, we're getting pretty close to that. So all these individual items here on the slide, we have proposed new standards for, and we have done some sort of implementation in our browser platform. And this is really important. So it's not enough to just propose standards, because actually, for many of these items, standards have been proposed, multiple standards over the last 5 years. The only problem was that nobody cared. If it's not a browser vendor who actually goes ahead and implements it, nobody's going to care. So there's a group called WAC, which is a group of operators and OEMs. They have actually multiple standards for contacts. I think there are 3 different contact standards right now. Nobody implemented them. That's what makes it different. So now a browser is actually coming in and is acknowledging, yeah, we have totally neglected the mobile web. We're going to go now and actually build all these APIs in practice, and that gives it immediately much more weight. The reason that it gives much more weight is that we are not just implementing this for these future boot-to-gecko devices, which I'm going to show you screenshots of in a moment. We're actually taking all these APIs, we are implementing them across our entire product spectrum. So I told you we have half a billion users on desktop and on mobile. And all these APIs, we're implementing everywhere it makes sense. So the camera API, for example, we are implementing equally on desktop and on mobile. And we have also an offering on Android, so even on the existing platforms, we can offer you a browser with the necessary camera APIs. Telephony even. So telephony makes a lot of sense on mobile, right? You can use a radio, but even on desktop actually it makes a lot of sense because you can add an API, so things like Skype can integrate the browser and provide those dialing services. So most of these APIs make sense across all these different devices, and we can take all these APIs and push them into all the existing this deployed software we have. So as a result, developers don't have to wait. If you want to use any of these features, all you need is a recent version of Firefox, and you can start developing against these APIs. That's what gives this a lot more emphasis than if like a consortium like WAC 3 years ago makes some standard content. Because 30% of the web will be able to use these capabilities pretty soon. Pardon? So networking is, first of all, networking is kind of part of the web stack already. There's only WebSockets and a couple other things like that. But yes, there's actually capabilities really beyond that. So we have additional proposals for TCP and UDP APIs for HTML1. Good point. Actually, now we have our surprise visitor here. Might want to join me.
Oh my God.
So Brendan Eich, our CTO, is going to join us today and going to help me out with my presentation since my voice might die.
Hi.
All right, next slide. feel free to jump in anytime. So the system we are trying to go towards is that we would like to build a device that really is completely based on a web stack. So the idea is you turn on this device, it boots an operating system kernel, it boots a rendering engine, a web engine, and it immediately goes to an HTML5 content. So the home screen, the dialer, the contact setting, the notification bar, anything on the phone, all the logic, all the user interface stuff, everything is built using HTML5. And in such a system, it becomes really more like a cloud-based phone. Everything is conceptually in HTML5 web app, and we can very nicely apply a lot of the technology that already exists on the web. So actually, for this kind of device, all you have to add is these APIs that are shown. Most of the technology that's already out on the web translates very directly. So how does it compare to existing systems? So if you look at existing stacks, it doesn't really matter what stacks you choose, whether it's iOS or Android, they all have the same structure, right? You have a device, you have a kernel, you have some API layer, or you have native APIs that you have to program against if you want to make the actual user experience of the device. So Android's home screen, for example, is written in this native API-based system called Dalvik. And on top of that sits the actual browser with the web content. So what we are building here is very different because we are building the same device and kernel layer, but then directly on top of that we put the web engine. So the web content and the actual device experience all run on top of the web content. And an interesting outcome of squeezing out this native parts of the system is actually we are building a much slimmer stack. A lot of the stuff that's in Dalvik, for example, really duplicates the web stack. Dalvik can do stuff like render pixels on a screen, play audio, play video, take touch it. That's the same things the web can do as well. So in these additional stacks, you tend to have a lot of duplicated code active. You have the API stuff that does all these things. You have the web browser that does the same things, basically. And in our system, this doesn't exist. And just squeezing everything out and do everything is the web stack. So one thing we already observed is that we can actually end up being able to build devices that have substantially less memory requirements and CPU requirements than this existing Android or iOS devices. And this is really interesting for some of the operator partners we are working with to bring these devices to market, because we can suddenly make smartphone devices with a great web experience at a much lower price point than you can today with an Android or an iOS device.
Also of interest to the chipset makers, because the low-end chipset doesn't run Android 4, it just doesn't fit.
So one step that's missing here, of course, in the explanation so far, is how do apps work here? So the web is already a very capable platform. You can do really cool things with it. You can do all sorts of applications. But what really is changing is that we are moving away from the concept of like navigating a site and a document. We're moving towards a world where the browser is no longer these things, a URL bar and like tabs. It becomes an HTML5 runtime. So amongst others, you start running these apps on your web engine, the browser kind of gets out of the way. It gives you the full screen, you have the touch interface, and you're responsible to really do all the user interaction. And there's actually quite a bit of work associated with that. So trivially in the system, you can take a little manifest, I will show you the format in a second, and wrap it around the web page, and it looks like a web app. But to really make a web app efficient, there's a couple more steps necessary. You have to do things like offline caching for responsive behavior, and also make sure that you nicely optimize your UI for mobile. So this leads us to this concept of open web app. So we have defined a simple manifest format I'm about to show that you can take, and it takes some metadata and adds it to a site, basically. Things like, this is the icon of my site, this is the name, this is who makes this web app. There might be a payment required, so this is the kind of payment you require, and that's the kind of payment channels you accept in return. And this is manifest, you can turn any website into a web app. But again, there's a couple additional steps necessary to turn it into a good web app. So the manifest itself is very straightforward, as I said. There's stuff like icons you can list here, and the developer who made this, what marketplaces you allow to install this application. This is important for payments. So if you expect certain payments to be paid, then you can log into a marketplace, and only those marketplaces are allowed to process your payments. And then there's some localization information, and that's it. So this is a simple JSON file, basically. You add this to your website. We suggest an extension .web app for this. And then the moment you do that, someone can come along with a device that supports web apps, which in the near future includes Firefox desktop and Firefox mobile, and of course boot-to-gecko devices. And through a marketplace or other discovery mechanisms, they can go and install this site as a web application. This is kind of step one. This is a minimal step. Let's talk a little bit about how we actually optimize this content to make it a really compelling and competitive experience with native APIs. So the first thing that's interesting is that you don't have to go through a marketplace actually. There's a JavaScript API where you can trigger installation yourself. This facilitates a couple interesting flows. For example, if you happen to be the New York Times and a user comes by, and you have created a web app like this, then you can go and manually trigger an installation right there. So if you see the user keeps coming back to your site, you can offer a little pop-up, hey, you see the likes content, you want to install this in the web app. So we think this is really important. Because again, marketplaces are like, marketplaces is a way you find content today. Who knows how you're going to find content tomorrow? This is a nice way how you can do direct discovery of content along the way. Now, the next part is pretty important, is app cache. On these phone devices here, they use two things. If you click on something to start it, you want it to start immediately. And also, if you don't have a data connection, most of your apps still make sense to play offline and offline. For example, might just run offline. So this is really important to make good use of app caching. There's a very simple app cache manifest. I recommend you depth on it a little bit. The API seems to be not very much beloved by most JavaScript developers. So we are very interested in feedback from you. If you start using app cache and you think it's really bad, you should tell us, and if you have ideas to make it better, we really would like to hear that. Because offline caching is a really critical part of the system.
It's part of HTML5. For simple apps, it seems to work well. For apps with lots of different sub-apps, like Lanyard, which is a social site for conference attendees, it doesn't work, it doesn't scale. You have to write manifests for every possible conference.
We did the same things from like other large sites, like social networking sites. They have to try to use offline caching, so use network caching, network transitions, and it's very, very difficult to scale to large sites. But for simple content, it works pretty well. So we're actually using this for all the applications on the phone. The boot-to-gecko device, all parts of the system, the home screen, the dialer, the contacts application, they're all web applications. They all have a web app manifest, and they all have an app cache manifest. So we can pre-cache it on the device. So these devices work offline without network connection, exactly because they have a web app manifest and an app cache file that allows the web engine on the device to have all the content available.
So Cloud Phone sounds like you always have to be connected, but it's not true.
And the discovery beyond the marketplace, I already talked about briefly. That this is where you use the JavaScript API, so you can kind of do and you can offer users to install applications as they custom content. And we should really go wild on what's possible here, right? Like if instead the New York Times, think of something like Facebook, right? Your friends play a game and you decide discovers that you have very similar interests. They can offer you, hey, you want to install the same game? It's a very simple dialogue. So,
social discovery.
Yeah, social discovery of apps. So this is exactly why we're trying to break open these silos, because there's so many cooler ways to discover apps and then to have some party control the marketplace. An important part of this is that Mozilla is in a process right now of building a marketplace because we think it's important to implement what we're proposing here. But it's not the only marketplace. So on these devices, you can install more marketplaces. If you think you can run a marketplace better than us, which is not entirely unlikely, you're free to do that. Or if you're a part like Amazon, there's a lot of market rate, a lot of developer relationships, you can build your own marketplace. So for us, we have a certain profile for a marketplace in mind. We think that we have, for example, a certain brand, and users trust us. We tend to be associated with security and privacy. So we might curate a certain set of apps where we pay particular attention to things that correspond to our brand values. And you might have a different marketplace idea. Maybe you have a really cool and fun marketplace with lots of games in it. So we can build these different marketplaces, different discovery mechanisms. We can very nicely compete against each other. And that's really the goal here. Like that we create a system where there's competition, not just one silo. All right, another piece that I wanted to briefly mention is browser ID. So one problem we run into on the web is that right now it's really difficult to associate permanent state of stuff that you, for example, that you have purchased something. You go and buy a web app. Where's that stored? In your browser? It doesn't really make sense. Right?
iTunes.
If you have a phone, you're going to take your content with you. HTML5, so for a change, it actually works. If you buy an HTML5 web app on your phone, you can take it on your desktop. It's all just HTML5 to translate very nicely. The main reason you can't take that with you is because if it's attached to the device, it's stuck there. So instead, what we're proposing is that really all the stuff that you buy or all the stuff that you touch and use should be attached to your identity, and this is what browser ID is for. So browser ID is a federated identity system that makes it very easy for websites to identify you. They can basically ask the browser, hey, who is the user? And then as a user, you can decide whether you grant access to one of your identities that you've installed. And the site can go and then attach your stuff to your identity. So if you buy the app, for example, the app is enabled for that identity. And if you sign in with the same identity to multiple devices, then on all those devices you can access the same app.
Sure. This browser ID, does it support unique encryption?
So the way the protocol works is secure. It's a cryptographic protocol. So when your identity provider issues you a certificate, you can then sign on at multiple sites. Those sites do not contact the identity provider. The identity provider does not see your sign-ons.
Okay.
So unlike Facebook Connect, where not only does the relying party call Facebook, Facebook gives back some social data to the relying party, leaks some of their social data. It's sort of a goodie for the site. It's an incentive to use Facebook Connect, to be fair. With browser ID, we're actually more privacy conscious. So the identity provider gives you a certificate. It's sort of a public-private key pair, asymmetric public key cryptography. And then you can use that to log in anywhere. And it's good for up to a certain amount of time.
So I'm asking in the context of content protection.
Yeah, so you could build DRM off this. That's sort of Mozilla's position on DRM is controversial because Hollywood will not die easily on this. They're going to die hard.
Yeah.
But we don't want a bunch of data coffins where your movies die like this thing. We want your identity to be the key, so your media lives with you wherever you go, and that's based on browser ID.
That's kind of the long-term story. So a couple of years from now, we really would like Hollywood to come to the senses and allow you to take your stuff.
I'm very familiar with the DRM discussion.
To be honest, in the short term, we're looking at very simple existing DRM systems. We don't think it's a good solution, but that's really what Hollywood requires you to do today. There's also certain non-open video codecs that unfortunately uses today to deliver video. So in some of these areas, we have to compromise. We have to make it,
but federated.
Yeah. So we have to make a device we want to use. For that, we need to make sure we can play the content we want to play. In some cases, that means that we have to make some compromises. But I think browser ID is a very nice long-term story. It's clear how you can use that to enable things like DRM and purchasing applications and other forms of content and ebooks and what have you. So I have a couple of screenshots here from the current Gaia UI that I will show you at the end of the talk how you can get that onto a phone. And I just wanted to explain a little bit what you see. So this is a lock screen here. This is, again, it's all pure HTML5. It's the first thing that comes up when you boot the device. So you boot into a rendering engine, and then this is just an HTML5 page. Basically indexed with HTML, what's on the device, app attached. This is loaded, and what you see here is an image tag. This is some JavaScript code that manipulates some div to set the type. And even on top of here, you see this traditional phone status bar, right? There's a carrier on the left here. This is coming from the network status API, actually. So JavaScript pulls it all the network status API. On the right-hand side, you have the battery status. This is from the battery status API that you support across all different platforms. So Mac, the Mac laptop, for example, here that is giving the presentation. You can already today clear the battery status. And then a couple of other like signal strengths and stuff like that. So this is completely HTML5, all the logic here is in JavaScript. Another cool thing that I like to show people is, how many of you have heard of do not track? Do not track. All right, you should definitely Google for that. So do not track is a standard we have proposed. It's basically a header that the browser is sending, indicating to servers that my user does not want to be tracked. And this works by the user opting in. So the user explicitly expresses to the browser, I do not want to be tracked by ad networks. And then we broadcast that signal out to servers. And in a world where all your network traffic goes through HTML and HTTP, this is really nice because it means that in this device, at a very basic fundamental level, you can enable do not track. And you tell all the apps and everything you talk to is, I don't want to be tracked. So we can do privacy-conserving features at a very, very low level, much lower than in the existing stack. Where like some of the apps are native and they communicate with God knows what protocols, where it's much harder to enforce this kind of common standards. Another interesting piece here is the browser actually. So we have a Firefox browser on this device, but what's different from the existing implementations is that this browser here actually is completely HTML5. So the menu you see here, there's just a div, there's some CSS styling, the URL bar, that's all CSS and HTML. And then we have an extension to iframes that allow us to build a browser where you can manipulate the history and navigate forward and back. So really all parts of the system, every piece of it is built with HTML5. Now, one area where we have to invest quite a bit of work is actually make sure that the web is really fast enough for some of these things. If you buy a phone, you expect it to be very efficient, and you expect 60 frames per second animations. And there's quite a few interesting tricks. We're going to start blogging about these on our hacks blog, which talks about interesting developer topics. we invest a lot of time in doing GPU-based optimization on these devices. So if you know how to set up the HTML5 content, and you understand a little bit the heuristics that browsers tend to use to display your content, you can make sure that you align your code in a way that it executes very efficiently, and you can run it to a texture. I mean, for example, panning on the home screen here, so you're moving the home screen content back and forth. You can run it once, and then just use the GPU to move textures around, which is very, very fast. The browser does not have to re-render, which is CPU intensive and slow. All right, I think we're getting pretty close to our time limit. So I want to make sure I wrap this up, and then we can open up this for questions. This is our home screen here. Same concept again. There's a background image, a couple of images on top of this here. This is the old home screen design that you can currently see in the system when you download it. And I actually also bought some slides of the new UX design that has just been proposed. So it's kind of a sneak peek. We are in the process right now of finalizing the final UX design and start implementing that. So in a couple of weeks, you will see these things land in a repository, but in the meantime, it kind of gives you an impression what the system is going to look like. The goal really is, when you buy this phone and look at the phone, you're not supposed to be able to really tell that it's an HTML5 device. That's not the point. We're not trying to make a device that intentionally looks different. But we're trying to make the device that's pleasing and performant, and it's a cool smartphone. And we just happen to build this open technology. So the goal is really to make a competitive product. And HTML5 has made the technology platform to do that. All right, one last point I wanted to make is we are building this boot-to-gecko project. And we are putting a bunch of new cool things into our web platform, Gecko. That's the rendering engine inside Firefox, which we are also using in this project. As I said, we have around 30% market share. How do we get this to the other browsers, in the other 70%? And for that, I just wanted to show you a little story. So last year, sometime on August 17th, the tech lead of this project, Chris Jones, filed a bug saying that I was trying to build the home screen. I want to have some haptic feedback, and I can't vibrate the device. There's no HTML5 API for that. So we need an API to do that. And he filed the bug, and about 3 months later, in November, we actually had a patch for it. So we made a patch, we made a prototype API, and we implemented it in boot-to-gecko, and then later on also in Android. So it took us about 3 months to really come up with a prototype and build that. And shortly thereafter, actually around the same time that the patch was landed, on the W3C mailing list that talks about this kind of device APIs, someone picked up the fact that we are working on this API and said, hey, this is really cool. We should make a standard out of this. This is a really simple, compelling API. We think other browser vendors will want to implement this as well.
Nokia.
This person on Nokia, by the way. So this is interesting because Nokia is not currently a majority user. So they have some small fragment that are using Firefox or Gecko, but most of the phones do not use our system. Most of them are based on Windows Trident's platform. So Nokia is simply an OEM that likes the feature. So their guy said, okay, we'd like to have this as a standard. This is really cool. And then shortly thereafter, maybe another few years later, some guy from Samsung, another OEM that makes devices, said, oh, this is really cool. We would like to implement this in WebKit. Which is another very popular web engine for mobile devices. Open source as well. It's made by Apple and Microsoft. So you can see that very quickly all these other parties jumped into the party and said, yeah, this is cool, we would like to implement this as well. So basically, this is 4 months. We went from having an idea that we need this on the web to basically most relevant browser engines supporting this in one way or another. So this is really what makes the web amazing, is that over a very short period of time, we can add these standards.
If they're bite-sized, this is a smaller API, just vibration motor control, not huge. Easy to agree on without change.
And what's really cool is that we can basically use our rendering engine. We can put new features in there, apply pressure onto others to have to extend their platforms. So we never had to go and build something in the WebKit. We could just drive their agenda by adding something that then they were under competitive pressure to add to their platform as well.
I'm on WebKit Dev, the mailing list, and Samsung had to get the patch past Apple's gatekeepers. They said, oh, shouldn't we have a unified theory of vibration? Aren't gamepads also vibration motor enabled? And that was just a kind of token objection because it got through. Because these are bite-sized and it's better to make incremental progress than try to hold it up for a perfect theory of vibration.
So that's one very interesting note. So Google and Apple, the actual owners of the WebKit platform, were not really as active in this thread. It was Samsung that did the implementation.
Nokia.
Nokia driving the standard. So it basically means that Google and Apple might be maybe not so keen on the web moving very fast, right? Because they deny silos. The longer the web is sucky on mobile, the longer their silos are going to exist. But there's enough other parties that have a committed interest in the web or mobile succeeding that they're going to push the platform through Google and Apple. Now, I think this is one of the reasons that we have actually a pretty good chance of success. And if you look at the history, there's some pretty spectacular failures. And I just heard we have someone from here who's working with the WebOS platform, so I'm going to tread very carefully here. HP Palm tried to build a similar system they called WebOS. And I'm going to give you my interpretation why it failed, and then maybe other people have a critique or other suggestions why it failed. But I think a big reason for that failure is that HP and Palm were not really web companies. They could not push the web forward the way we can. So when we added the device vibration API, we added that to every version of Firefox where it makes sense. On desktop, most desktops don't have a haptic feedback device, but in Firefox for Android, for example, they added it as well in addition to these upcoming devices. So we could move a large number of users immediately on this API. And that's really what forced all the other browser vendors to do the same.
Mozilla knows how to do web standards, and been doing it forever.
So I think this is our advantage. We can move the web platform, whereas HP and Palm, they had to build basically a framework that was proprietary to WebOS and you to kind of facilitate some of these things, because they could not easily push web standards. So that's why we think that we will be successful with this, where WebOS failed, because we don't have to put some Mozilla-specific glue on top of the web platform we have to program against.
They were a little early, to be fair, too. The big debut for Palm was at CES in 2009 early. WebKit wasn't quite as far along. It's in the secret sauce that makes the iPhone so great. It's not open source. We're a little bit more on time with this. Just the right time to do it now.
So that's one of the reasons that HP Palm were not so successful. And we think that we have quite a different story, because we can move the real web platform. We don't have to add some Mozilla-specific code on top of that. People don't want to program against it. And then, of course, Microsoft has been trying for the last couple of months very intensively to establish a third platform. You saw that on my slides earlier, Windows Phone. Personally, I don't think it's going to succeed, and I'm going to tell you why. There's simply no room. There's no room for a third proprietary system, because Windows Phone 7 is the same thing as other platforms. There's like C# and XMA and a bunch of other Microsoft technologies. And
JavaScript too.
And some JavaScript too. And it's this like big soup of like proprietary stuff, and developers already sick and tired of Android and iOS. They don't want the third one they have to target. So we really think that the only third platform that's a chance is the web, because it's not a new platform. It's not like we are coming here and telling you, hey, we have this cool thing, it's called the web, you want to do whatever you want. It's already there. It happens to be kind of sucky in mobile, so we have to make it better. But it already exists. So we really think there's three platforms. There's iOS, there's Android, and there's the web. All we have to do is make the web really competitive, and then there should be much less lifting we have to do to convince you to move the applications over. And then the web is, of course, also different. Because it exists, there is already a lot of applications. So these boot-to-gecko devices, it's often very trivial to bring up existing web content. We were at JSConf, a JavaScript conference, and people at the conference were able to bring up existing web apps very quickly. Put a little manifest around it, maybe do some tuning for touch interface. There you go, you have a mobile app. So we're inheriting a rich amount of content. You don't have to start with zero and populating this device's content.
Starting with an empty ecosystem is very hard.
And then, of course, there's also no SDK, right? So that's usually like reporters, the first question they ask me is, where's the SDK editing, right? It's the web. Like, open your browser and whatever tools you use to edit HTML5, that's your SDK. With this support, we add some tool support. So we're working on the tooling and good emulation and a very faithful performance characteristics analysis. But that's just basically just a little like cherry on top. The basic framework you already have. And more importantly, we don't force you to use any specific frameworks. You can use Prototype or jQuery Touch, whatever you like. We might add our own framework that we recommend you to use, but we will make sure it's never required. It's only a tooling suggestion, not a requirement. All right, this is pretty much it for my talk. Here's a couple more links if you're interested in the project, how you can find us, how you can find the actual source code. I mentioned at the beginning, this is completely open source. And anything that I talked about here today is up on the web and in our repository.
From day one.
From day one. So this is where we try to be very different from Google. This is not a project that like Mozilla internally is doing some stuff and then we roll it out and when the phone is in the market and give you the source, maybe or maybe not. This is completely open from day one. So you can literally watch us build this.
And help.
And so someone had actually a phone device, and you can see these devices, like often stuff is broken when you pull a version from a repository because we are building it right now. You're literally watching us build this. All right, thank you very much.
Yeah, I have three questions. Sorry. Well, thank you very much for the presentation first. So the first question is, why do you need a web API? Because, for example, there are a number of tools such as Phonegap or Bay Area Mobile Meetup, and basically I could make the point that the native OS is like your kernel, and Phonegap is basically like the web API. So that's my first question. Second question, Tizen, Intel and Samsung seems that they have an open source project that looks very much. So that's the key, or what's the story here? And so
We should probably go through this, otherwise we're going to forget about
the third question is very quickly. What's the process that are you going to try to go to W3C or to standardize it?
Okay, let's take it backwards. We already have. If you go to my blog at BrendanEich.com, mobile web API evolution, we've already standardized a bunch of these because they are bite-sized. Vibration APIs in the last call, which is almost a standard, becomes an official recommendation after that step. All of these are in process at W3C. We proposed them as early as possible, starting last fall. So these are all going through like boom, boom, boom. We're not holding them back. They're being standardized, they're being put into WebKit by Samsung mostly. So the second question, Tizen. Samsung started with something called Samsung Linux Platform. And last summer they were still keen on it, but it involved native clients written in Extra in C++ or C. So it's not going to take off any more than Windows. It's another native platform, it's proprietary. Around the time we launched boot-to-gecko, we talked to them, and then after that they were very keen on Tizen, which has an HTML5 application basis. So our hope is that because they've been implementing these APIs in WebKit, applications that run in boot-to-gecko will also run in Tizen. Applications that run in Tizen will run in boot-to-gecko. This is two implementations, two instances of a new category, the web as the third platform for mobile devices. And to your first question, Phonegap, there's also Titanium. There are other ways of bridging or compiling web applications to run as native applications, to be wrapped in native code and put into an app store. But they don't agree on what the APIs are. They all differ. Phonegap's very nice. It has APIs for vibration and SMS and so on. But they are not standards. You can't just take one of them and standardize it because it isn't the same as the others. You have to agree on what the common interface is. What we proposed is more in the spirit of existing web APIs like the DOM. We propose incremental additions to the document object model that are for these different device APIs. And they're very close to Titanium and Phonegap, but they're not exactly the same. And the Phonegap guys, some of whom are friends of mine, are big fans of this because they want to adapt Phonegap to be a very thin shim on top of these standard APIs. As these standards become recommendations, official standards of W3C, and are implemented in WebKit, Gecko, Microsoft, and ultimately shipped in iOS, Phonegap should just boil away to be a thin adaptation layer in APIs. Eventually, it just disappears. So you can't standardize one of these early adapter systems like Phonegap. They're good. They help people get apps early when there was no standard. But as the standards roll out, the standards carry more weight because there's a common agreement between the vendors.
So will this eliminate any noticeable difference between this versus a native to be developed app? Or will those be a distinctive differences still noticeable, but at least?
So this almost depends on the definition of the word native. So to be honest, I understand that the definition of native, an application that feels like it belongs in this device, right? It's touch interface, it's efficient, it starts quickly, it works offline. That's what I understand on native. Today, you can achieve that on an Android device really only with Java code. What we are working on is to make sure you can do that with HTML5 as well. So it's not like native HTML5 application if you so want. If you use native machine code, yes, that's a good time to eliminate. So in this system, everything you're building HTML5, it's super standard with JavaScript. You don't have to write some Java code or some scary
But the tricky thing here, the political thing, is that Apple and Google can put their finger on the scale. If they want their native stacks to be privileged, especially if they're using patents, they can say, oh, 3D tabs, right? WWDC is upon us. Some 3D, extra secret sauce in the user interface is only available to the native tab. And we can do 3D on the web with WebGL, but it's going to be a little more work. And if we fold it in, we might be under patent, so we don't know. I'm not a lawyer. So there's always the opportunity here that native can be a little ahead of the web and a little ahead of the standards. But the web is the people's platform. It's the great mediator. It's why all these other companies like Samsung, Nokia, Mozilla, Microsoft even are all agreeing on these standards because they can't afford to make their own and splinter it into the 4th, the 5th, and the 6th, and the 7th platform. They have to agree on the web. So in the long run, just as we saw with the PC, my bet is on the web.
It's important to note that but the applications they talk about here, they don't just work on these upcoming future devices that will be in the market at some point January or February next year. You can use the same technologies, you can use the web app manifest, you can app cache to build devices, to build these applications today for Android devices running Firefox and Android. And you can do some limitations, you can run the same applications on Safari and iOS as well. There's no web app support yet, but maybe soon Apple is going to add also support for the manifest format, so the installation process is a little bit smoother. But the basic idea is that HTML5 is already on all these devices. It's not equally good everywhere. So the device we are building is really built from the bottom up for HTML5. You will probably get the best, most optimized experience on that. But you will get some experience in Android as well, and you will have some reasonable execution on iOS as well. So that's really what the web is so powerful, that you get this broad reach across all these different sites already today.
Do you have a model for background services? Because that was one of the things that was sucky on WebOS for the longest time. You couldn't check
yes, so there's actually 2 or 3 different ways. You can run this multitasking basically. If you think of tabs in the browser, in the system you can have multiple tabs. The difference is that there's one tab owns the full screen at any given time, but you can have multiple apps open. There's also a concept of like background workers and shared workers and basically an invisible tab if you so want. So there's various different levels of resource and capabilities that we offer you for the background service.
Yeah, definitely want something that doesn't take up a lot of resource. You don't want the full DOM loading.
Yeah, so exactly. So there's like shared workers, which does not do that, and there's also a way to. Often on Android devices, background services are used for polling, for example. So we work with operators in a very efficient push notification protocol that sits directly on the operator's network and delivers very efficiently without constant keep alive packets notifications to these devices. That's one of the advantages of working with partners. So we are working with a bunch of operators and OEMs and chipset makers to bring these devices to market. And everyone basically brings the pieces they are best familiar. So Mozilla really knows the web stack, and the operator really knows the network and how they can optimize the notification stuff. So we are building very much an open system. If you look at the repository, you can see that many different parties across the industry are contributing to this project.
It's GitHub. So we're using UDP for notifications.
I hope I misunderstood you, but did you say that Phonegap would be compromised against standards that are going to be changing?
I think compromise is not the right word. So
standardized.
Standardized, yeah. So if you look at our APIs that we have proposed, and some of which have already been standardized by W3C, some of which are still going through the standardized process, they're often very similar, right? So they are sometimes not identical, but pretty similar. And they're pretty, my understanding of Phonegap really is that it's a temporary clutch, right? Like right now, you cannot do this on Android. We're going to give you this Phonegap thing. It's going to make it possible to do it today. In 2 or 3 years, when there's a proper standard in the browser how to do it, that piece of Phonegap can be removed. So it's simply a way to take Phonegap APIs or Phonegap-like APIs, add them to the whole thing. You don't need the shim for that anymore. So over time, the need for Phonegap is going to be lesser, for sure.
So think about how Phonegap works on Android. If you want to vibrate for a second or 2 seconds, you have to call a Java API that runs the vibration motor for that long. And so Phonegap generates code and it calls the Java compiler and builds an app for you. But if the API is part of your web stack, all you need to do is have that JavaScript turn directly into a call, a shim that forwards to the native API, which serves as JavaScript.
So Firefox is my favorite browser, except on a mobile device. I have an Android that I bought like last November, so it's relatively fast. And Android browser is like the IE6 of mobile, except that Firefox mobile is about 5 to 6 times slower than it is. I just tried typing an address in, and the latency was so bad that I couldn't tell if the app was hanging or not communicating with the keyboard. So
I have a story about this. So you're running, I think you're clearly running the officially released Firefox for Android,
right.
codenamed Fennec. Thanks mostly to Andreas, Chris Jones, and Patrick Walton and Mozilla, we've had a redo of it, which is in beta right now. It's about to be released this month. It redoes Firefox using a native Java user interface, still has Gecko. It's very fast to start, very fast to interact with. The problem with the one you're running is we tried to use the same desktop cross-platform toolkit that we use on Firefox on Windows, Mac, and Linux. And on mobile, it's just harder because the CPU is slower. We tried separating processes so you have more responsiveness in the user interface, even if the layout engine is laying out the page. That just used more memory. So that architecture was a problem, and thanks to Andreas' leadership, we switched to a better architecture. You should try that at the beta. It's really good.
It's in the store as well.
It's night and day.
If you search for Firefox beta in the store, you can try the current beta version, and you will be very pleasantly surprised.
Very good ratings on the beta.
Thanks very much.
I have a development workflow kind of question. So today, if I'm developing for iOS, let's say, I might be building my HTML5 app and testing it in Safari on the desktop. But before I'm going to deploy it, I definitely want to test it in the iOS simulator, run it on their browser, just to make sure there aren't any hiccups. What's your recommendation for developing for boot-to-gecko if you don't have a device that boot-to-gecko on?
So I can tell you what we do today, like how the front-end team is building all these boot-to-gecko like dialer and home screen apps. And I can explain to you a little bit what our longer-term story is over the next couple of months, what's going to be available. So today we actually do a lot of development in Firefox. Firefox is a bunch of developer tools, and then an inspector for HTML5, and then breakpoints and whatnot for JavaScript. So since it's the same rendering engine in Firefox and on these devices, a lot of the apps you can develop directly in Firefox. And we're adding a bunch of tooling in addition to that. So the first set of tools that will be available pretty soon is in the developer menu, you will have the ability to restrict the screen size, for example, like the smaller device screens that you have on these phone devices. You can switch from like mouse input to touch input and emulate a bunch of other events. You can emulate, for example, like the home screen button was pressed and these kind of things. So that's really the first step. And we add a couple of like developer tool aids to the browser that we make it easier to develop this device. And we already have currently an emulator actually. So you can, if you have to right now build it yourself for some silly legal reasons. These phone devices have a couple of video codecs amongst others that haven't. If a manufacturer is selling you hardware, they can do that. As Mozilla, it's a little bit more tricky for us to give you patent codecs. So in a couple of weeks, hopefully, we have resolved that issue, and then we can make available to you a download of an emulator that runs the whole stack with the actual code that runs on these phone devices as well. So you have very faithful emulation of the entire device stack, with all the performance characteristics.
Great.
I heard about where the name Mozilla came from. Where did Gecko come from?
For Brendan's answer.
So long ago, Netscape had a project called, I guess, the JavaGator. It was trying to rewrite the Netscape browser of the 90s fame that had at one point 80% of the browser market in Java. That all came crashing down as Netscape was being crushed by Microsoft because Microsoft bundled IE with Windows 95 and 98 and tied it into the OS. So the team that built that rendering engine for the JavaGator quickly saw which way the wind was blowing and rewrote it in C++. And they needed a new name for it. They called it Raptor because I guess Jurassic Park 3 was out or something. But when we adopted it in Mozilla in late 1998, we'd open sourced in March 31st, 1998, April Fool's Day, when we realized that our old code that we released to the world was open source, while it was hackable, and some people have done clever things, like they put the secure sockets layer back in. We weren't allowed to ship that at the time. It was an electronic munition. We had to have some people in Australia and New Zealand put it back in for us. That was about the extent of the hacks that were done on it, because the code base was quite hacked over by 4 generations of Netscape. So we needed a cleaner code base to switch to. And I looked at Raptor, this C++ redo of Java code. It was incomplete. It was like my first browser engine, but it was also very standards oriented, and there were a lot of green fields for open source volunteers to come in and contribute to. And I said, this is going to take 4 years. This is the classic do not rewrite in software, as Joel Bolsky said. Big mistake for Netscape, but for Mozilla it was good because when we picked Raptor, we had a clean slate, and we had to rename it because of some patent or trademark issue, Jurassic Park, who knows. So we came up with Gecko. And,
Okay, I thought maybe
that's
it
it.
was Warren Buffett, you're going to get acquired.
No Gordon Gecko, no acquisitions. And so this was a disaster for Netscape because they kept thinking they were going to ship a browser and make a comeback against IE. And AOL, which had bought Netscape, thought, oh great, any day now we'll beat IE and we can switch the Windows AOL client to the Gecko engine, and it didn't happen. But about 4 years later, in 2002, Mozilla reached 1.0, and with help from Dave Hyatt, who left Netscape to go to Apple, create Safari, and Blake Ross, who's now at Facebook, we created what became Firefox. And that took off like a rocket in 2004, and Gecko's the engine the whole way through.
How will the HTML5 video tag be implemented? Are you guys going to do that like iOS for protect people's bandwidth and what?
So for the video tag, the video tag is a very painful discussion topic from Mozilla. You can Google for some of the more recent discussions on that. Mozilla has been pushing for a long time open video standards. And unfortunately, it never really took off on the web. There's a long
unencumbered
ones, yeah. And for some reasons I don't want to go into that have much to do with a lot of other companies that proposed open unencumbered standards, but that didn't really follow up on really using them. It never really took off. On the web today, almost all the videos are in a format if you need a patent license to play back. So we made a decision at Mozilla that if you want to make a competitive browser, you must be able to play the content you would like to see. And most of the content you want to see is unfortunately in H.264, for example. So fortunately, actually, most devices these days, desktop devices, but in particular mobile devices, there's already decoders on those devices. So on this platform, that's basically what we're doing is that if you go to an OEM and they make a device, they will automatically put a decoder on that device already, most in hardware actually for battery configuration. And we just wire our Gecko engine up to be able to play to that codec. So if you have a video tag, you can play H.264 and it goes to the hardware capabilities of the device, and the OEM has to pay somewhere the patent mafia for that. On desktop, actually, we're doing a very similar thing. So in many desktop devices today, you have H.264, and we are step-by-step considering implementing those to support those as well.
And we always relied on Flash where we didn't use the OS decoder anyway, so we're always using something, some kind of plug-in to handle H.264. And it is very battery conscious to use the hardware. The hardware can actually use less power playing a movie than if you just are browsing around and tapping.
But are you going to allow like iOS that it just ignores like any preload and any preload attributes of the HTML5 tag? Are you guys going to do the same thing? I mean, and that's so that you have to. The user has physical control of downloading the video and starting it, and the volume controls. I mean, what decision are you guys?
Part of that is about memory constraints. So yes, if we have to, we will. I don't think we've dug into that yet.
To be honest, that's part of the stack I'm not familiar with either. There's a trade-off between like doing that and if the standard requires you to behave a certain way. If you diverge from the standard, you might be breaking some content. On mobile, unfortunately, because predominantly the same web engine is the rendering engine, WebKit is used everywhere. WebKit is actually more relevant as a standard than whatever the standard documents say. So there's some sort of trade-off. Whatever makes sense, we can do there. I don't think we're particularly religious about details or solutions.
Speaking of hardware dependencies here, two questions. One is there's a bunch of sensors, native hard sensors that go into these small phones, from GPS to gyro sensors, accelerometers, to hardware graphics accelerators. How are you guys dealing with that? How do you compare against native OS like Android versus iOS?
So it's a very simple answer.
The second question is, to really cut to the chase, if you're going to be, the end story is going to be very successful, boot-to-gecko, then you have to have these device makers natively supporting you guys, shipping these gadgets, right? Not aftermarket, but at the point of manufacturing, shipping it platform with the devices. How are you guys doing in terms of getting the OEMs actually adopting it?
So these APIs were already in play, like I said. Some of those you mentioned are already done. Like the accelerometer was already in Gecko for desktop, like your MacBook, you could play the game when you tilt it. And that was already surfaced as a web API even before we started boot-to-gecko. Location was also done that way. So some of these are still in play in the standards body, but they're implemented. We've got all the sensors mapped. Deutsche Telekom partner on boot-to-gecko in its innovation lab has done near-field communications, which they showed at JSCon. All these sensors being covered. This is not a difficult problem for us because, as you say, the hardware is there. It's almost commoditized. And the sort of device layer, the standard Linux open source that's shared among all the hardware manufacturers, it's even shared by Android, is there.
The second part of your question, currently some of the devices with boot-to-gecko only to see, they use commercial hardware for their purpose. You take an Android device and turn it into a boot-to-gecko device.
Nexus S, whatever.
that is not how these devices are going to go to market. So we are not interested really in the aftermarket part. It's a tiny market. Very few people on this planet will want to do that. So the way these devices are going to hit the market early next year is going to be a very traditional story. You go into a store and there's the Android aisle, the iOS aisle, and then there's a product aisle that is based on boot-to-gecko. Boot-to-gecko as your project name, not a product name. You will never see it on the product, I promise. So there's a bunch of different like naming and marketing things going on right now to determine what the final product name is. Telefonica, one of the operators we work together with, they have already announced that they will bring one of these devices into the Latin American market. So these are very traditional devices. And as a result of that, we're working with Qualcomm, a chipset maker, and 2 OEMs by now, to make specifically devices for this. One thing that comes in very handy here is that we actually are reusing a bunch of lower parts of the stack. So if you go back to this architecture diagram I showed here, we're actually using the same device and kernel layer that Android is based on as well. So Android uses Linux kernel, they're using the same kind of Linux kernel, we're using the same kind of device drivers and abstractions that Android uses as well. So by importing the same open source projects, Android is based on OEMs that you can very quickly bring up the stack. So usually we give the OEMs, or they get a copy of our stack on our repository, and just in a couple of days they can bring up this device and they can very cheaply switch their manufacturing from an Android device over to a boot-to-gecko based device.
We aren't writing any new device drivers. We're not writing a new operating system layer, kernel layer. We're using Linux.
What would you say the primary advantages are of boot-to-gecko over something just like a well-implemented browser within one of these silos?
So the integration is really this picture here. So a browser is something like this, right? Yeah, there's a URL bar and tabs and stuff like that. You're really offering a much more integrated device experience. So this is all parts of the system mesh up. They're all HTML5. Think of the dialer, for example. Today, a dialer usually has like a numeric dial pad and maybe a list of contacts coming from a SIM card. By going to HTML5 for that, you enable entirely new possible applications, right? If you were to work for a popular social networking site with a blue logo, and you decide, let's make a dialer, you can do that. And you make a dialer where like you log into your account and suddenly all your friends are there. If you want to make a phone call, you click on the dialer and you click on a friend you want to talk to. Instead of like having to enter deals and phone numbers and names and stuff.
You can't do that in the browser on iOS. You can't do that in Safari, which is the only browser on iOS. You cannot have a dialer application.
Or if you have a new idea for home screen, right? You don't like
that's the problem with the browser.
Is it?
Not the platform.
Yes,
the platform does not surface the API to the browser.
But
yeah.
It's between the two.
Apple, we know, is its own baby, but the problem being all this is the browser, not the capability of the web.
Not really, because the browser here sits on these native APIs and often very restricted.
Yes,
Android, for
again,
example.
we're talking about the browser.
No, this is restricted. This here, not the browser. So on Android, for example, you cannot take an incoming phone call on top of this platform. You have to sit in here. So the dialer is implemented using some magic Java API only Google can touch. The browser cannot implement a dialer or receive phone calls or receive SMS.
Same for Android or Apple.
So many of the capabilities that we surface are simply not accessible because Google would like to control this. Like if there's any kind of like other dialing than the built-in dialer, Google wants it to be their voice over P service. They don't want to do random over P systems, right? Because you might be making money.
That's a political thing, not a technology.
I would say it's political. This middleware layer is point control, whereas our middleware is really gone. We've lowered the stack, and it's the web end, and it has dialing as well as rendering and JavaScript. It's all there.
That's actually a very good observation. This stack is not closed for technical reasons. It's strictly only closed for political reasons, control reasons.
So how do you stop arbitrary pieces of JavaScript dialing on that?
Very good question. So we have a pretty elaborate security model. If you want to go to our website, you can read up about it, since that's probably will take a little bit more time than we have here. But the basic idea is that if it's a low privileged operation, and you want to like a full screen or things like that, where there's a minimal risk to it, but it's something the user understands, then we can ask the user. We can ask you, are you okay with this game using full screen? And you can decide that. And when it gets to more high-risk APIs, such as dialing, we use more advanced security mechanisms. So for the dialer, for example, that's pretty much an extreme case, because the operator, in many cases, is liable for that dialer working a certain way. So 911 dialing, for example, must always work. So it's still HTML5, it's still open technology. You can still build the dialer, but actually you have to go to the operator and make sure that the operator is okay with you using your dialer on devices that operate sold to people through OEM.
And there could be only one.
Yeah. So some of the very privileged APIs, the system is not as open as the web usually for everything else, simply for kind of legal reasons we can't easily work around. But the idea is the standards are still there. You can build a dialer, and you can use this on these devices as long as you meet the necessary certification steps.
There's a permission model which includes some exclusive high-powered apps, but also involves user-granted trust. So we're not trying to make what Android has done, which allows a bunch of applications to be bundled with permissions when you install them. So the user is asked, you're installing a high-end social networking app, should it be able to take your contacts list and upload it? Is there any good reason for that? We require interaction at the point of the action, not on install time in general.
So I have a specific use case. I have an Android app and an iOS app. Both the UIs are implemented natively, so Java and Objective-C. But both these apps talk to a common C++ code via NDK on Android and directly on Objective-C. So if I was to build a web app for boot-to-gecko, would I still be able to leverage this C++ code?
Yeah, actually you are. So we have a project called Mscripton that's being done in our research group. You can very easily find it on our website. And that's actually a compiler that takes C++ code and translates it for JavaScript. And we already successfully used this for a bunch of games. There's a bunch of OpenGL 3D games and first-person shooters that were translated from C++ on an automated way to JavaScript. And this works particularly well if you have some sort of engine ready to go, right? Like a 3D engine or an audio processing engine, some sort of computational stuff where stuff comes in and falls on the other end. It's a perfect use case for that.
If you go on YouTube and look for my name, Brendan Eich, and Fluent, at an O'Reilly conference last week, I demoed a first-person shooter game, open source engine called Sourbound, mapped via Mscripton to Firefox. It runs 60 frames a second.
So you're the same Brendan and then at Java Service?
The conference was Fluent.
Fluent.
You mentioned monetization of your apps and things like that, and I think something that's always in the back of my mind with HTML5 apps that are distributed through the web is use source, right? People use the App Store as a way of monetizing because they've locked in their code. How do you guys handle that?
So there's kind of two answers for that. First of all, view source is pretty much equivalent to like to ship on Android. If you Android ship bytecode, you can very easily compile bytecode backwards and into source code. So Java bytecode and source code are already roughly equivalent, so that doesn't make a big difference. On top of that, of course, you can obfuscate code quite a bit. So a lot of the JavaScript code that is shipped today is actually obfuscated, mostly also just for compression reasons. You can take on all the textual names and you put in shorter, meaningless names. Now, on top of that, though, to be honest, I think most of the value of web apps comes in through cloud. So if you have a large game assets are really what's valuable, not really your JavaScript code itself. So in many cases, those assets are loaded from the web. So you have some game, and like every level you have to load from the web once you're starting to pay it. That's where things like browser ID come in very handy.
It's like an MMORPG will have an identity system. Could use browser ID, could use its own. You have to log in. To get on any leaderboard, you have to authenticate. That's all in the cloud.
So there's all these cloud parts you can authenticate and only enable if the user actually bought the service that you want to monetize, or like a new site, right, a new screen. That's where you can control it. So many of the cool parts that have value are really based on the server side.
So speaking of gaming and whatnot, is the B2G web engine going to be supporting Canvas?
Absolutely, yeah.
We actually had Canvas in 2004. I demoed it at the very first Web 2.0 conference in a lightning talk. We prototyped it based on proposals from Apple to what was then the very early What working group, which created HTML5, which is now WPC draft standard.
It's important to note that for us, there's no such thing as the mobile web or the boot-to-gecko subset of that. For us, it's just HTML5. So anything you can use on a desktop, you can do on these boot-to-gecko devices and on our Android version, for Android version of Firefox. It's the same rendering engine inside of it and the same things that we support.
Can I ask a second question? So, what about the accessibility and the accessibility APIs and whatnot? I mean, where does that factor into life?
Mozilla is a big supporter of ARIA and W3C, and Dave Bolter, of course, in Toronto, and we have other people working on accessibility engineers. ARIA is not the last word. There's more to do by a long shot, right? And I think some people checklist item these things and say, "Oh, ARIA, we're done, accessible," right? That's not true. We're very sensitive to that. You know, one of our engineers is blind, so We're still working on it. It's like the web. The web is always a work in progress. People say, oh, the web is so messy, it's never done. The native stacks are also never done. They're just wrapped up in pretty packages every release. iOS 5 is a thing of beauty, but the web always catches up, and we're here at Mozilla to push it on.
But the thing is that ARIA is the communication layer to accessible APIs on the different platforms, right? Whether it's the Windows platform or Windows platform or whatnot. I mean, where's the accessibility API platform in BTG?
The goal is to use the same.
You know, you've got ARIA, but what's ARIA talking to?
Okay, so actually there's more of a story there because ARIA, I wish it were the layer, right? There's a lot of IE6 out there. There's still a lot of like COM objects being integrated in very custom Windows-owned ways. We try not to have any kind of custom OS stuff. We don't service it as an API. We want to stick with only the web and the DOM and ARIA. So the way it maps is directly through Gecko, which has an accessibility module. You can look at it in the source tree. You can find the module owner and the module owner list. So we're implementing this directly on the web. We don't have some kind of secret OS sauce there.
The name of the app in there.
The name is abstracted out so you can look.
So then your accessibility feature kind of pick this up and like read it to you.
Okay, but so, and I know that you guys are like really big supporters of NVDA. I mean, I'm deep in that area, right? So are you going to be bundling something like NVDA into boot-to-gecko? I mean, what's going to make it accessible to a blind person, right? I mean,
yes. What's the screen reader? I think that is still ahead of us.
Some of this is also going to be OEM distributed. So there will be devices that will have better support for screen readers. There will be devices maybe that don't have as great support. This is the area where the device makers will also innovate. Our charge or the way we are pushing them is to make sure that every device has a good basic support.
I met someone who was also blind, a professor at UMD. She was still using JAWS, IE something. In some ways, the web is still catching up in that area, but Mozilla is investing heavily. We're pushing it ahead.
So if I have an existing Phonegap app that uses the Phonegap API, how easy is it to bring over?
If you have this view, we can probably do it here in a couple minutes. It's not a big deal yet. Many of the APIs really look very similar.
We talked to Brian LaRue, who's a friend at Adobe, Phonegap fan. He's a very funny speaker too. He's totally a fan of boot-to-gecko. He wants to make Phonegap go away, or at least become a shim library directly on top of his APIs. We're going to meet with him soon.
Guys, want two more questions?
All right.
How do you think the communication down the road, like between Chrome and Firefox?
Chrome. What kind of communications do you need?
General.
Oh, competition. Okay. Well, so yes, Google is probably Mozilla's most intense competitor, right? The idea that they're only going after IE is kind of a friendly myth because they're going to take share wherever they can get it. Firefox, our job is to compete and be effective, not just be open and embrace standards, but be actually good for users. I use Chrome and Firefox every day. I find Chrome is better for containing Flash, and even then it runs away almost every day on me. I have beach balling, I have CPU hogging, I have to kill Flash or kill the Chrome process that contains Flash. I have a lot of tabs open, so there's joined renderers. Chrome does not process isolate every single tab. That's not true either. They up to 20, and then they start joining them. I use Firefox, and lately I've turned off Flash, to tell you the truth, because once I do that, Firefox is quite competitive. Things I like better in Firefox than Chrome are the awesome bar, the URL bar, where it remembers my recently visited pages. I can search my local history. It's highly private. It doesn't go off and ask Google for suggestions. I find that much better than Chrome, which has an omnibox that is always going to Google Suggest. So Big Brother is telling me that I want to see Britney Spears when I really wanted to look, for Britain. So I use these browsers every day because I'm interested in the competitive threat that Chrome poses to us. And I see, apart from Flash, I see, especially in the latest Firefox, like the Nightly, I see a lot of good in Firefox. But we are working hard to compete. And Google is a huge company. They're formidable. I give them credit for doing Chrome. I don't give them any market share. So we're there to fight for the user.
So you were speaking earlier about how Android and iOS are locked down. And it's my understanding, I might be wrong on this, but Google is getting stricter, like in later versions of it, because of the fragmentation, because there are so many different devices and capabilities.
Android is, yes.
And how are you guys going to address that with Gaia?
There's a couple, so Gaia is just a user interface that sits on top of the system. What you're really asking is, how can we avoid fragmentation of HTML5? And there actually, so the bad news is HTML5 is already fragmented.
Yeah.
The good news is that we ended up with a system, the way HTML5 is steered, that actually is pretty tolerant of the fragmentation. So web authors do things like feature detection and wasteful degradation of certain features to deal with the fact that there are different capabilities on different HTML5 renderers. And on top of that, we have a standards process. This is not like where every OEM is sticking their own stuff in there. We have a standards process where we can all meet at W3C and we can negotiate what these joint APIs should look like. And in the end, browsers tend to very quickly converge on these final APIs. So I think the web has simply a much more compelling story how to contain that fragmentation. That's why we don't have to go and assert this kind of control. And I have heard the same stories. I can't speak for Google, but I have read the same articles that in future versions of Android, there will be even stricter rules that OEMs can change or they cannot.
Oh, the Open Handset Alliance, rules have changed. They've gotten stricter, for sure.
And we think we don't need that because we have HTML5, which is this actively self-managing system where fragmentation is simply a natural part of the system, but it's also this natural counterforce.
And above that, which is powerful in itself, I think you will see Mozilla using its brand and its users' trust in these devices. You'll see, we're partnering with Telefonica. My belief is that you'll see Mozilla brands as well as Telefonica brands.
All right, thank you very much.